Okay, cool. So that's one example. Let me do another one just like this. It's almost identical, actually, the next one. Basically, instead of 12, you would actually have 5. So we're supposing now the area is 5 square centimeters. And what we want to do is, again, find the radius and the diameter. Okay, so it's really just like before, right? We're going to let R be the radius. I mean, you could use other notation if you want, but you do have to remember the area formula, pi times the R squared, or pi times the radius squared. You have to do. So what we have then is pi times R squared equals 5. Here it's in centimeters, so square centimeters. Remember, area is always your unit squared, the unit of length squared. So from here, we're going to get pi times R squared is 5 square centimeters. And then it's just like before, same process. Namely, first we divide by 5, okay? Well, you know what I mean. God darn it. Yeah, as you can see, PowerPoint does have a pen feature, but since I have to use the mouse, it doesn't always come out nice. So we have the pi's cancel here. We divide both sides by pi. We get R squared is 5 square centimeters over pi. But again, we don't want R squared. We want R. That's what we want. Okay, so what do? Well, we're going to take square roots. So we get R is the square root of 5 square centimeters over pi. And again, this is the same thing. The centimeters squared you could just bring out. For this, as someone asked, which was a really good question, I would do 5 divided by pi first, okay? And then whatever you get, take the square root of. And if you do that, you will get 1 point. You'll get this number here. And again, I will tell you how many decimal places to round to. And if you do that, if you round to 3, at the third decimal place, we have a 5 here, right? That tells us the third decimal place, since we're rounding to it, is going to go up 1 digit. So we get this. Like so. And again, since we also want the diameter, what you do is you just multiply this number by 2. Again, you really don't want any rounding to occur until the very end. And if you're rounding to 3 decimal places, you want to use more than 3 decimal places. I mean, here I use 6. So again, we have this number and we multiply it by 2. That we would round to get the diameter. Okay. So that example was good. I hope that makes sense to everyone. Remember, I can't see the chat, so if you have a question, use that hand raise feature. All right. Yeah?
Do you prefer if we leave the centimeter, like or whatever it would be, like inches, meters, whatever, until we square root it out, until we put it back in at the end? Or can we take it as we're like doing the equations? Can we take those extra letters out and then just kind of go through and then put them back on at the end?
You mean not have the units here?
Exactly, yeah.
That should be fine. As long as you have the correct unit at the very end, that should be fine.
Okay, thank you.
You're welcome. Good question. Okay. All right, awesome. Okay. Any other questions? Okay. So now, here's what I want to do next. We're going to do a little bit more with perimeter and area, but we're going to work with two-dimensional figures, two-dimensional shapes, that is, But they're not going to be simple things like squares, rectangles. They're going to be, I guess, how do I say this? Like funny looking shapes, as you'll see what I mean. And just remember, when dealing with these kinds of shapes, to find the perimeter, again, you want to get the distance around the outside of the shape. Okay? Or again, if you imagine walking along the boundary of it, you would want to know, well, how far are you going to actually walk? And again, you do that, you're going to add together the length of each side that's on the outside of it. Now for area, it's the same idea. Well, no, I shouldn't say that. For area, what you're going to do, you could also do this for perimeter if necessary. To handle area, you're going to break up the region into shapes that you know the area formulas for. I mean, you'll see when we do some examples. I understand it sounds a little confusing, and there's more in the book as well. But you're going to break up the region into something like squares, rectangles, circles, parallelograms, triangles, things that you know area formulas for. You may have to draw lines within the region. That's okay. You can do that. That won't change the area. That said, let's go on to our first example, which is this. Now, just to note, I would actually, if this was on a quiz or something, I would actually tell you that these dashed lines are not part of the shape, but they will come into play, as you'll see. But let's say we wanted to get the perimeter of this shape. I'm not sure what kind of shape this is, but it's actually not that bad to calculate, right? To get the perimeter, I mean, the calculations here, you just have to add the length of each line segment that makes up the boundary. And again, the dashed lines are not part of the shape, so you would, for now, ignore it. But hopefully you can see, though, that you would actually have 18 centimeters plus 6 centimeters plus 6 centimeters plus 9.5 centimeters plus 11 centimeters, 3 centimeters, and 6. You would add up all those lengths and get 59.5 centimeters, right? Because that's the length of each segment that makes up the boundary. In other words, it's the distance around the object. Or again, if you want, you can imagine starting somewhere, walking in one direction, and then you would see how far did you walk. But you can't walk on the dashed line, so to say. Okay, so that's for perimeter, and that hopefully wasn't too bad. But now the question is, what about area? I mean, this is not, some shape like a square or something, right? That we know the formula for the area of, that is. So it looks like we're in trouble, right? Well, not quite. Okay, you might be able to see it just by looking at this, but it looks like we almost have a rectangle here, right? If we had a line segment here, we would have a rectangle and a triangle. And that's what this slide is trying to illustrate, right? This was the original. But if I drew a dashed line here, right, I'm breaking up the region into a rectangle and a triangle. We know the area of a rectangle, right? We know how to find it. Same thing with the triangle. So all we have to do then is get the area of the rectangle and get the area of the triangle and add them together. Okay, so again, this was the original, right? This is what I was trying to say before. Sometimes you will have to draw in a dashed line like this to break up the region. And then you take the area of each piece. And sometimes there might be more than one way to accomplish that. I mean, this was the only way I could think of. Okay. So how do we get the area of each thing? Well, the rectangle is pretty easy, right? We know the dimensions of it. We know its width is 6 centimeters and its length is 18 centimeters. So the area of the rectangle is pretty easy, right? It's just 18 centimeters times 6 centimeters. For the triangle, what do we need? We need the base and the height, right? Then it's just 1/2 base times height. But how do we get the height? Well, that's what this is. Okay. That's what the 9 centimeters is, right? You can see that's the height of the triangle. I mean, hopefully you can see that. I mean, it might be kind of hard to see from these lines here, but hopefully you can see that these two dashed lines form a 90-degree angle. Okay. What about the base, though? Well, that's this dashed line, right? Now, how would you get that? Well, 1 second, let me finish, please. How would we get that? Well, notice this side here is 18 centimeters, right? So this side has to be 18 centimeters as well, because we have a rectangle. 3 centimeters is accounted for, so is 6. So there's 9 centimeters remaining. That's what this has to be then. So the base length of this triangle is 9 centimeters. The height is also 9 centimeters. So we can get the area. And that's what we do here. We have the area of the rectangle, right? 18 centimeters times 6 centimeters, which is 108 square centimeters. Here's the triangle. And so for the area for the entire shape, you just add them up. Okay, I think someone had a question, I think.
Never mind.
I guess not. Okay. Okay. I thought someone had a question, so okay. All right.
Never mind, sorry. I thought,
I can't hear you.
I said never mind.
She's just saying never mind.
Okay, sorry, it's hard for me to hear, so okay. Thank you. Okay, I know that question was a little intimidating. I understand that. And although I know some of these questions can be not terrible, but they can be a little intimidating. So, but again, it's just the idea is not terrible. So it does take a little visualization, but you know, you get that with practice. So, all right. Okay. Any other questions? Let me get the recording.